In this video, I'll be going over our notes for how we can write equations of parallel and perpendicular lines. Remember that two lines that are parallel are going to have the same slope. So parallel line symbol looks like two L's next to each other, so they'll be written like that, and they're going to have the same exact slope. But two lines that are perpendicular are going to have slopes that are opposite reciprocals. So we've seen this a little bit before already, and we've kind of practiced with it, but today we're going to be practicing how we can apply this into the actual equations of the lines. The symbol for lines being perpendicular is an upside down T. Remember that parallel lines will never intersect, but perpendicular lines intersect at a 90-degree angle. So in our first example, we're going to be given an equation of a line, and then we're going to be asked to come up with the equations for lines that are both parallel and perpendicular to the same line. So if I see this line C has the equation y equals negative 5 over 2x plus 10. This is an equation in slope-intercept form, so I can see that my slope is negative 5 over 2 and my y-intercept is 10. So when I see my first task, it says to write the equation of a line D that would be parallel to line C, but it must pass through the point 6, 8. So if it's going to need to be parallel to our original line, then it's going to need a slope that is exactly the same. So we're going to need to use that same slope. But we're going to also need to apply the point that it's asking us to go through. So we need to make sure that we go through the point x1, y1, which is 6, 8. So since we know the slope and we know the point, we're going to need to use point slope form here. So we're going to start by writing y minus our y1, which is 8, equals our slope, negative 5 over 2, times the quantity x minus x1, which is 6. So this has now put all of the pieces into point slope form, and we're going to solve it to get slope-intercept form. So I'm going to distribute my negative 5 halves over here. So I'll be left with negative 5 halves x. And then we have a negative 5 times negative 6, which is positive 30, divided by 2 will be positive 15. Then I need to add 8 to both sides, so I'll be left with negative 5 over 2x plus 23 as my equation of this line. In our next example, we're asked to use the same line, but we're going to write a line that's perpendicular to line C and passes through this point. So we want to come up with the opposite reciprocal slope. Remember, to find the opposite reciprocal, you need to flip the fraction and change the sign. So I'm going from negative to positive, and 5 over 2 becomes 2 over 5. So that'll be the slope that I need to use. I need to go through the point 4, 3, which is my new x1, y1. So I'm going to have y minus my y1 value of 3 equal to my slope of 2/5 times the quantity x minus x1, which is 4. So this is in point slope form, and we're going to go ahead and simplify it into slope-intercept form. So on my right side, I need to distribute the 2/5. So I'll have 2/5 x minus 8/5. Then I'm going to add 3. So I have y equals 2/5 x minus 8/5 plus 3. So because we have that, I'm going to show that work over here. We're adding 3. It's over 1, so we need to multiply it by 5 over 5 to get the same denominator. So we have negative 8/5 plus 15/5. So if we add those together, we're left with 7/5. So positive 7/5 as our new y-intercept. And that would be the equation of our line that is perpendicular and going through that particular point. So you need to find the original slope of the line, decide how to write a new slope, whether it's parallel or perpendicular, and then use point slope form if you're asked to go through a particular point. In example 2, we're asked to write the equation in slope-intercept form of a line M that has a slope of 3 and passes through the point 3, 14. So we have a slope of 3, and then we're given that x1, y1 is a point on our line at 3, 14. So because we only have a point and a slope, we're going to need to use point slope form. So we'll have y minus 14 is equal to the slope m times the quantity x minus 3. Then we're going to distribute on the right side. So we're left with 3x minus 9. We'll add 14 to both sides, so we're left with 3x plus 5. So that is our original line here. In the next two parts, we're going to be asked to write an equation for lines that are both parallel and perpendicular to that line that we just solved for. So that line we just solved for has a slope of 3. We'll need to use that down below with these new points given. So if you want to pause the video and try this on your own, please feel free to go ahead and check your work when you are ready. In this example, we're asked to write the parallel line, and it needs to go through the point -3, -5. So since it's going to be parallel, it needs the same slope. And since it's going through this point, we're going to need to use point slope form again. So we'll do y minus -5, subtracting a negative makes a positive. We'll set that equal to our slope of 3 times the quantity x minus -3, so again adding because we subtracted a negative. Then we're going to go ahead and distribute, so we have y plus 5 equals 9x plus 9, and then we're going to subtract 5, so y equals 9, oh sorry, made a mistake, 3x, not 9x, 3x plus 9, and then when we subtract our 5, we get 3x plus 4. So again, we see that the slopes are matching. They have slightly different y-intercept, but they would be parallel to one another because their slopes are the same. In the second part, we're looking for the line that's perpendicular. So remember, to find the perpendicular slope, we need to take the opposite reciprocal slope. So 3 over by itself is like 3 over 1 because any number can be rewritten over 1 and it doesn't change the value. So if I want to flip this and get the reciprocal, I get 1/3. And since it started as a positive, I need to make it a -1/3. So I'll be applying that along with my x1, y1, the point that we were asked to go through in the graph. So we're going to have y minus -8, minus a negative makes a positive, our slope of -1/3. We're going to take x minus -2, so we're going to be adding 2 there because minus a negative is a positive. And then we need to go ahead and distribute. So we'll have y plus 8 equals -1/3 x minus 2/3. So then we need to subtract 8. So y is going to equal -1/3 x, and then we have -2/3 minus 8. 8 is over 1. We need to multiply it by 3 over 3 to get the same denominator. So we'll have -2/3 minus 24/3. So we're really left with -26/3, which you can leave as an improper fraction, or if you'd want to, you could make it -8 and 2/3 because 3 times 8 is 24 and you have 2 left over. So you could make it that mixed number if you want, but we'll leave it in this form as our final answer. In our next example, we are given a graph and then we need to determine the equation of the line, and we'll eventually be asked to plot a line that is parallel and perpendicular. So with this graph, we want to look and see if we can find the y-intercept. So when I look at this, I can see that it is going through this nice coordinate right here at -3 on the y-axis. So I can see that I have a y-intercept at -3. And then to find the slope, I just need to find another point that I need to go to in order to figure out how much am I rising, how much am I running. So this point looks nice. I'm going to rise 4 and run 2. So my slope is up 4 to the right 2, which simplifies to a slope of +2. So that means that my slope-intercept form would be y equals mx plus b, and I'm filling in those values, so 2x minus 3 for this line that we started with. Now notice that there is a point on this graph. It is at the coordinate -4, +3. That point is going to be what we're using in our next two examples. In the next example, it says write the equation of a line in slope-intercept form that is parallel to the given line and goes through the point given. So remember that our line that we started with was y equals 2x minus 3. That's our original given line. So if we're asked in this example to write an equation of a line that is parallel, we are going to have to use the same slope, so slope of 2. The x1, y1 value that we're going to be trying to go through is -4, +3. So -4, 3. So you have a couple options here. You can just start doing your slope since you know it's going to be the same. You could go up 2 over 1, up 2 over 1, up 2 over 1, and keep going. And we can go down 2 and to the left 1 to go the opposite. And this actually gives us a nice picture of our line. Now, we could do this and kind of see where we think it might end up going through on the y-intercept. However, it is off of our graph, so we are going to need to use our point slope form here in order to help us figure out the final equation. So we're going to do y minus y1, which is 3, is equal to our slope times x minus x1, so minus a negative is positive 4 there. And then we're going to go ahead and simplify. So distribute your 2. 2x plus 8 is what we get on the right side. We're going to add 3 to both sides, so 2x plus 11 becomes our final equation there. And that seems to make sense because if we had gone 2 more boxes up from 9, we would have been crossing right there at positive 11, so that seems to work with what we had drawn. Now that we look at this graph that we drew, we can tell that these lines do look parallel. They're never going to be intersecting because they have that same slope. So we have checked to see if it is parallel, and it appears to be. And lastly, we're asked to write an equation of a line in slope-intercept form that is perpendicular to that given line and goes through the point. So we are still starting with the same equation, y equals 2x minus 3. We still have that point, negative 4, 3, that we want to go through. But this time we want a line that is perpendicular. So remember, for perpendicular, we need to write an opposite reciprocal slope. My original slope was 2 over 1. So the opposite reciprocal will be 1/2 as a reciprocal, and changing it from positive to negative. So we need a slope of negative 1/2. So again, we can use the graphing method to kind of help us see where we're going to be here. So I need to go down 1 and to the right 2, down 1, right 2, down 1, right 2. And I'm going to keep doing that until I can get a nice picture of my line. And then I'm going to go ahead and carefully connect my dots there. So I've just now graphed my line. It does appear to be parallel, and we need to figure out what the equation is. So you have two choices here. You can use point-slope form with the slope and the point that were given to you. Or you can use the graph. Since we've just plotted it from that point using that opposite reciprocal slope, we can see that we're going through that positive 1. So just to make sure we graphed right, let's use point-slope form and make sure that our equation comes out correctly. So we'll do y minus y1, which is 3, equals the negative 1/2 slope times x minus negative 4. So plus subtracting a negative becomes positive. We're going to distribute our 1/2. So we have negative 1/2 x minus 2. And then we're going to add 3 to both sides. So negative 1/2 x plus 1 should be our equation. We can see that we have a y-intercept at positive 1. And if we go down 1 to the left 2, down 1 and to the right 2, we are creating every other point on our line. So that matches what we had drawn. Our equation looks like it matches that correctly, and we can see that we have those perpendicular lines on our graph, so it is perpendicular as we planned.